Black holes and their formation. A black hole is one of the most mysterious and fascinating objects in the universe. It is a region in space where gravity is so strong that nothing, not even light, can escape from it. Because light cannot get out, black holes are invisible. Astronomers can only detect them by observing the effects of their gravity on nearby stars, gas, or light. Black holes form when very massive stars reach the end of their lives. Every star is in a constant battle between gravity, which tries to pull all the matter inward, and the pressure from nuclear fusion, which pushes outward. Fusion happens when hydrogen atoms combine to form helium, releasing a tremendous amount of energy. This energy creates an outward pressure that balances the inward pull of gravity. However, when a massive star, at least 3 times heavier than the Sun, runs out of nuclear fuel, fusion stops. Without that outward pressure, gravity wins. The star collapses in on itself. The core of the star shrinks and becomes extremely dense. If the mass is large enough, the collapse continues until the star becomes a black hole. The boundary around a black hole is called the event horizon. It marks the point of no return. Once something crosses the event horizon, it cannot escape. Even light, which travels faster than anything else in the universe, cannot get away. The distance from the center of the black hole to the event horizon depends on its mass. The larger the black hole, the larger its event horizon. At the center of a black hole lies what scientists call the singularity. It is a point of infinite density and zero volume where the laws of physics as we know them break down. Time and space behave in strange ways near the singularity. Theoretically, the gravitational pull there is so intense that it bends space-time infinitely. However, our current understanding of physics, including Einstein's theory of general relativity, cannot fully explain what happens inside the singularity. There are several types of black holes. The smallest ones are stellar mass black holes, which form from collapsing stars. Then there are supermassive black holes, which are millions or even billions times more massive than the Sun. These are found at the centers of most galaxies, including our own Milky Way. Astronomers believe that supermassive black holes may have formed from the merging of smaller black holes or from enormous clouds of gas collapsing in the early universe. There are also intermediate and primordial black holes, which are thought to be smaller or formed in the early moments after the Big Bang, though these are still theoretical.
There are several types of black holes. The smallest ones are stellar mass black holes, which form from collapsing stars. Then there are supermassive black holes, which are millions or even billions of times more massive than the Sun. These are found at the centers of most galaxies, including our own Milky Way. Astronomers believe that supermassive black holes may have formed from the merging of smaller black holes or from enormous clouds of gas collapsing in the early universe. There are also intermediate and primordial black holes, which are thought to be smaller or formed in the early moments after the Big Bang, though these are still theoretical. Black holes do not simply suck everything around them like a cosmic vacuum cleaner. Objects can orbit a black hole safely if they are far enough away, just like planets orbit stars. It is only when something gets too close to the event horizon that it gets pulled in. When matter falls toward a black hole, it forms a rapidly spinning disk called an accretion disk. The matter in this disk heats up due to friction and releases powerful X-rays and radiation. Astronomers detect these emissions to study black holes indirectly. In 2019, scientists captured the first ever image of a black hole's shadow using the Event Horizon Telescope, a network of radio telescopes across the globe. The black hole photographed lies in the center of the galaxy M87, about 55 million light-years away. This achievement confirmed many predictions of Einstein's theory and provided direct evidence of black holes' existence. Black holes also play a key role in the structure and evolution of galaxies. They influence the motion of stars, control the flow of gas, and may even regulate star formation. Some black holes shoot out powerful jets of charged particles at nearly the speed of light, which can extend for thousands of light years into space. These jets carry enormous amounts of energy and shape their surroundings in dramatic ways. Another fascinating aspect of black holes is Hawking radiation, a concept proposed by the physicist Stephen Hawking. According to quantum theory, black holes can slowly lose mass and energy through tiny particles escaping from just outside the event horizon. Over incredibly long timescales, this could cause black holes to evaporate completely. While Hawking radiation has not yet been directly observed, it remains an important idea that connects quantum mechanics with general relativity. The study of black holes continues to challenge our understanding of physics, space, and time. They are both destroyers and creators, regions where matter disappears and yet give rise to new cosmic phenomena. Scientists use advanced telescopes, gravitational wave detectors, and computer simulations to learn more about them. Each new discovery about black holes brings us closer to understanding the most extreme and mysterious forces of the universe. In summary, black holes are formed from the collapse of massive stars and represent points in space where gravity is so strong that nothing can escape. They come in different sizes and play an important role in shaping galaxies and the universe itself. Though invisible, their influence can be felt across vast distances. Studying them helps scientists explore the deepest laws of nature and the limits of human knowledge about the cosmos.